All right, we are doing integration. No surprise, we're doing integration, but we're doing it by parts. More or less, this is the biggest rabbit hole when it comes to integration. These are questions that are the most wild when it comes to integration. Pretty much everything so far with integration.
Good morning, after
Good morning.
Just a friendly reminder to students, remember, just in case you forgot, cell phones, headphones, AirPods, hats, hoodies are not permitted in school. Again, cell phones, headphones, AirPods, hats and hoodies are not permitted in school. Have a fine day. Thank you.
So far we've been doing integration. Everything is pretty much within our control. We feel relatively confident. We're just doing our integration. Our rules work great. We're pretty much always following the idea that power rule is the way to go. We've seen a few things like U substitution, which maybe was a little bit messy, but in the end, U substitution is pretty easy. But here we get into integration by parts, and it is just a wild, wild west of craziness. Have you guys ever heard of the integration bee?
I know MIT, yeah.
So MIT, fancy college, pretty smart kids. They have a spelling bee, but instead of a spelling bee, they have an integration bee. So they put up a really hard problem and they ask you to integrate it. And obviously it is more difficult than the integration of x squared. A lot of times it uses tons of different methods altogether, but integration by parts is basically the key to how do you make a hard question in integration, at least at the level that we're at. We're not going to be anywhere near the integration B level, I promise you that. But check out these 4 questions that I've written on the board. And they all are posing a problem, okay? The issue is multiplication is pretty much a dead end for us when it comes to integration, unless we can actually just multiply the stuff using either distributing, foiling, binomial expansion maybe, which we haven't really done a lot of, but maybe. Or we could use U substitution and hope that one is kind of the derivative of the other. And all of these have the problem of there's 2 things multiplied together and we're just stuck. One is not the derivative of the other. We cannot multiply them together to make it nicer. For example, if we try this first one, the integration of x e to the x dx. They're multiplied, which is an issue. If we tried U substitution maybe, we could pick that U is e to the x and du is also e to the x. And then we would just get stuck, right? Because we're hoping to get rid of this x, but what we've got is e to the x, and it's just not gonna work. U substitution, it's no good. So what's going on is we have to use integration by parts, which is basically the product rule, trying to undo the product rule. And on the very first day of integration, we talked about how that doesn't sound very nice. That doesn't sound very easy to do because the product rule is f prime of x times g of x plus g of x, g prime of x times f of x. And in order to do the integral, all of this would have to be all 4 of these parts. There's only 2 parts right there. And so most of the time what that also means is that some of the pieces have ended up canceling out and perfectly made matches where you have a positive e to the x and a negative e to the x. And they're like kind of invisible here. And so it becomes very difficult to keep track of all that stuff. And so in comes integration by parts. It is a formula that we're gonna learn for integration, and it kind of is gonna look like this formula. So, all I can advise for you today is lock in on these notes because it's gonna get kind of crazy pretty fast. Okay, here is the formula that you're gonna be using. The integration, and this is the worst part about integration by parts, they use the letter U and V, which look almost the same. So my strategy is make the U have the little kickstand on it and draw the V as like a really wide V. Now maybe you're some handwriting god and your U's and V's look differently, but mine look exactly the same. So I'll do my best to kind of make it look like this. U times V prime dx is equal to U times V minus the integral of U prime V dx. I think this one's supposed to happen. I think we have a typo on the key. But we're so good we can spot it. I do not think we have a typo on the key. We're good. The key is the key for a reason. Okay. Here's our formula. It is basically built like the product rule. We have things that are being multiplied together. You can see we kind of have those two pieces somewhat similar to the product rule. You can kind of see how we have some U's and V's and some DV's and some DU's in there. Again, the strategy is that it's probably product rule where some of the pieces ended up canceling out. And so we need to kind of figure out which of those pieces did cancel out and kind of come up with them out of thin air. The most important thing for us to realize for now is that there's two pieces multiplied together. And one of those pieces we're gonna think about as being a derivative. So we're not just looking at F times G, we're looking at one of them could be F, the other one would have to be G prime, or the other way around. So, one of originals is derivative, okay? It's pretty tough to see right in the middle of a glare on the video, but that'll be okay. So, let's look at our question here. We've got the integral of x e to the x dx. Now, this to me is one of those topics where if you don't think about it too much, it's a little bit easier. If you try not to get caught up in, well, why does this work? How come we can do, and you just keep it real simple in your brain and do the procedure the way the procedure needs to happen, you'll be like, this isn't too hard. And then the second that you start trying to pry into figuring it out on like a deeper level, it's gonna get really complicated. We want to make a list of U, DU, V, and DV. Again, just like for the product rule, we're gonna have F and F prime, G and G prime. That's pretty much what's going on here. Now the difficulty is choosing these four things because you basically have a 50-50 choice. One of the originals needs to be U, just a boring U, just a simple U, and the other piece of the original needs to be the derivative. And so you have to kind of make the call on which is which. So we've got an x and an e to the x. One of them is gonna go into the top u, and one of them is gonna go into the bottom dv. My d looks like a u, it happens all the time. So 50-50, which one do you think should be the u? And I'll give you a hint. We're trying to make this look nicer, which means when we take the derivative of u, hopefully it becomes nicer. So which one of these, when we take the derivative, will actually take a derivative and kind of degrade down a level? The x. For the most part, we really like polynomials, x's, in that u position because they're gonna degrade with a derivative. If we had chosen e to the x there, it's gonna stick around and we're gonna have more e to the x's than we started with. That means that our other piece, the e to the x, must be our dv. Now that we have those two picked, we want to fill out the other two using derivatives and integrals. We already calculated really quickly that the derivative of x is 1 dx. And honestly, once you get into this, you don't really need to write dx, but you get the idea. And then we need to take the integral to go from dv back up to v. And what's the integral of e to the x? E to the x. Okay, so step 1, you need to pick your u and dv. Step number 2, we need to use our formula. So here's the strategy for using the formula, okay? The formula is u and v and u prime or du and v, just a regular v. So out of all of these, this dv will not be used again in the formula. That is a huge hiccup that people get into, is they start thinking that they need to use all 4 of those pieces that we kind of first build up, but that dv doesn't show back up again. So our formula would be u, which is x, v, which is e to the x, minus the integral of u prime or du, which is 1, okay, I'm not gonna write that, times v, which is e to the x dx. The reason we're not going to be using this again is because it's already got the integral built in for that v, to take the integral of the v. All right, now this is hopefully progress, but it's not an answer yet because our job is to take an integral and we still never really took the integral. We just rearranged some stuff around. So if this looks nicer, then we did a good job. Or remember, we had that 50-50 chance of how to pick these two. If you picked them wrong, instead of this being easier than before, it will be harder than before. And if it's harder than before, just stop and say, oops, I messed up, start over and pick it the other way around. So let's finish this question. The integral is easy. It would be negative e to the x plus c. And here is our answer. Now, how did that work? Where did this stuff come from? We should be able to check any integral question by using derivatives and going hopefully back to the beginning. So let's check really quick. This won't take very long at all. If we want to check using derivatives of our answer, this first piece is a product rule. So we'll take the derivative of the first, e to the x, plus leave the first one alone and take the derivative of the second, e to the x. Take the derivative of this piece, negative e to the x. and then take the derivative of c, it's just 0. We have an e to the x and a minus e to the x. And we get back to just x e to the x. So this did work great. It's a little bit kind of going out of the way, but in the end, we're able to solve this question that 15 minutes ago would have been a complete roadblock with no way to figure out how to do. Now, just to be thorough on the very first day that we do this, let's start this question again, e to the x dx. Let's go a little bit quicker and let's choose the wrong option, okay? So we're gonna need to figure out what is u, what is du, what is v, and what is dv. We decided correctly that x would be the top one of u, but let's put x down here, and then we'll put our e to the x up top. Again, we have that 50-50 choice to decide. Now let's take the derivative e to the x, take the integral 1/2 x squared. Remember, we're not going to be using this bottom one anymore once we figure that out. It's going to be 1/2 x squared e to the x minus the integral of 1/2 x squared e to the x dx. And like I said before, this piece is just extra. We don't really worry about that piece, but this integral piece has gone from x e to the x to now x squared e to the x. It is getting harder. It is not getting easier. We chose our parts wrong. We notice this is getting harder, so just stop. Give up, start the question over, and choose it correctly. Okay, let's do another one of these questions up here at the top. And you know what, maybe before we choose one of those that we were looking at earlier, let's get some help choosing which pieces we like. I found this pretty cool priority list. This priority list is helping you choose DV, the piece that you would want to integrate. So our priority list is basically things with relatively easy integrals, but not the easiest integrals either, because if we chose the easiest integral, then we would probably end up with our polynomial down in the integrals. So basically, last resort, natural log, arctangent, arcsine. We talked about those integrals. Ew, we don't really like those. Now, we do like e to the x, sine x, and cosine x, because they don't get a whole lot bigger, they don't get a whole lot messier, they just kind of stay the same size, and that's okay. And then in the middle, you kind of have your polynomials, your x's. We don't want to just jump ahead and always pick the polynomial for that, because the polynomials work pretty good in the first position. Okay. So, this polynomial list, or sorry, priority list, I thought was kind of nice. I never really had that back in the day. So let's look at this. Do you want to do a trig question with x cosine x? A longer but similar, maybe we don't do this one with e to the x, because it's very similar. It just has that little u substitution kind of changeable thing. Do we want to look at the x squared ln x? Let's do the trig.
Oh,
Let's start with trig. I'm sorry, I absolutely did the worst teacher thing ever where I ask you a question and I say, no. Worst teacher ever. Let's do the trig one. Because I think this is the most kind of straightforward one. Our priority list is helping us out, and we'll just be able to get right into it. So we've got u, du, v, and dv. One of these is the top u, one of these is the bottom dv. Our priority list for choosing dv tells us the best case scenario is to pick either e to the x's or sines and cosines. And so I'm gonna go ahead and choose that cosine is there for my dv, that x is my u, which is gonna be a pretty easy little process here. du is gonna be 1, the integral of cosine is sine. I'm not gonna be using dv anymore. I'm gonna do my pattern here of x sine x minus the integral of 1 sine x dx. I'm always gonna have a second step where I actually have to do the integral of that piece, but hopefully it looks easier than it did at the start, and it does. So I've got x sine x, the integral of sine. What's the integral of sine? Nice job, negative cosine. We already have this negative, so I'm gonna put plus cosine plus e. Now, just because it's our second question and maybe we're still doubters a little bit, really quick check using derivatives. I'll take the derivative of x, which will just leave me with sine x, and then I'll leave the x alone, take the derivative to get cosine x. I'll take the derivative of cosine x to give me negative sine x, take the derivative of plus c to get 0, minus sine plus sine, and I'm left over with x cosine x. It works great. Okay, let's do a long void together, and then we'll revisit those at the front, and I'll use those shorter, easier ones as practice for you to do. So let's look at this one. The integral of x squared e to the 3x dx. All right, we did already x e to the x, and we figured that out, and it wasn't too bad. This x squared e to the x does have another layer. It has that x squared on it. And as I'm kind of scheming and I'm thinking my u, du, v, and dv, my dv's like to be e's and sines and cosines, so I'm gonna put my e to the 3x as my dv. That means my x squared has to be my u. Last time we did this question, du was 1, and it basically just evaporated away, and it was excellent. But for this question, 2x, it is degrading, which is good, but it's not gone, which means it's gonna be sticking around and it might still be a bit messy. What's the integral of dv? 1/3 e to the 3x. That's like a u substitution. I'm just keeping track of that 3 If you're not sure, you can always take the derivative, and the 3 would come out to counteract the 1/3, and then we would get e to the 3x. Okay. We're never going to be using this one again. We need to use our little formula, which would be 1/3 x squared e to the 3x minus, that's my u and my v, the integral of, now I'm going to use my du and my v. Okay, we did try to break this up, integration by parts. We still have more work to do. We still need to take an integral. If we look at this piece and we think we're on the right track. This is definitely more complicated than we've seen before today. So far, pretty much we've just been dealing with x, and then the x disappears, and it's like, oh, beautiful. Now we're looking at something super easy. For this question, it's a bit messier. One thing I could do is I could look at these constants, like 2 and 1/3, and maybe I could organize myself a little bit by putting the 2 and the 1/3 out front as like a little 2/3, and then let's organize this a little bit better so it looks a little nicer. So, the question is, looking at this integral, is it easier, simpler, on the track to being solvable, or is it harder? What do you think?
On the track.
I think it's on the track, all right? It's not good enough actually yet, but this does look almost the same as x e to the x, which was a question we solved already. And we were able to solve that question using integration by parts. So guess what, boys?
We're gonna do it again.
We're running it back. And we are integrating by parts again. We're gonna set up u, du, v, and dv. dv's like to be e's and sines and cosines, so no brainer here. Du is going to be 1 dx. The integral, same thing as before, 1/3 e to the dx. Now, we've gotten to the point where we have that 1 finally showed up. We've gone from having 2 things that are going to be multiplied together to only having 1, which means we're going to be able to solve this question. But at every step along the way, we have been generating constants. And so probably a mistake that would happen is not with that like calculus-y stuff. It's just keeping track of all the little constants. So be careful. Making sure to keep track of the constants. This first piece has not changed and will not change. 1/3 x squared e to the 3x. That piece is fine. Then we have minus 2/3, and that is gonna be multiplied by the integral, which we're gonna spread out using by parts to be uv 1/3 x e to the 3x minus the integral of 1/3, maybe I put that 1/3 in front of my integral, e to the 3x dx. All right, this minus 2/3 is here because it was there from the integral before. Then I put parentheses because I need to make sure that all of this that's about to get spread out is multiplied by that negative 2/3. This is u and v, and x and a 1/3 e to 3x. And then this is the integral of du and v. Well, du is just 1, so that's why you don't really see anything else. And I put the 1/3 in front of the integral just to make it look a little bit simpler. Okay, now it is time to finish this question because I need to take the integral and I probably need to do a little bit of organizing my coefficients, my numbers, my fractions as well. Good news is the integral of this, pretty easy. We've had a lot of practice taking the integral of e to the 3x. So 1/3 x squared e to the 3x. Do you want to try distributing and integrating all in one step in your head, or do you want to leave it for 2 steps?
2 steps.
Okay, 2 steps. Minus 2/3. This piece is not going to change. This piece is going to be 1/3. What's the integral of e to the 3x? 1/3 e to the 3x. And plus. I'm just going to stick it out there because we don't need to multiply it by any other constants because it's already a mystery. So it doesn't matter if it's 2c or 1c, who cares? All right, we've got to the point where we have taken the integral. It is now time to tidy it up. This first piece is my favorite. Don't have to do anything. This piece is going to need to be distributed -2/3 to both of my remaining pieces. That's going to make this first one -2/9 x e to the 3x. And what would the coefficient be of my third term? What do you guys got? Wait on you.
Plus 2/27.
Perfect. Nice job, dude. Plus 2/27. That's a 2 on the top and a 3 on the bottom, making 27 e 3x. Now, that monstrosity is the integration of x squared e to the 3x. All of that mess, if we wanted to check, I don't want to check it. This power rule and this, I said power, this product rule and this product rule and this simple derivative would all make a bunch of terms and they would all have opposites except for x squared e to the 3x. There'd be one term left at the end. All right, that's integration by parts. It is in some ways kind of crazy and complicated, but in other ways, again, if you don't think about it too hard and you just follow the rules, figure out, okay, I need to use integration by parts because I have 2 things that are multiplied and I can't actually multiply them. Get your u, du, v, dv. One's on the top, one's on the bottom. Make sure that you choose correctly. And I say make sure. If you get it wrong, it's just going to cost you 2 minutes, okay? If you just say, oh crap, this is going the wrong direction, start over. And then a lot of it is just organizing. Keep your u's and your v's organized. Keep your coefficients organized, your fractions in control. Okay, what we're gonna do now is, I promise, without cutting you off, I presented 4 questions at the beginning, and we have done the e to the x question and the trig question, but there are still 2 questions left that were posed at the beginning. This one, this e to the x, is probably the easiest because we've done 2 out of 3 of our questions with e to the x's. This natural log question, maybe a little bit harder. So, try one of these and we'll see how it goes. and we'll talk about the answers and pick whichever one you want. If you want to work as a group, if you want to try to decide together what should be U, what should be DV, however you want to set that up, you can go for it.